This is a tutorial on solving quadratic equations by completing the square. Completing the square is just another method to factor a quadratic equation. If we had the quadratic x squared plus bx plus c, where b and c are just numbers, we could factor that most likely into two binomials that would look like x plus p times x plus q, where p and q are just numbers. And when we do that, we would realize that our linear coefficient, b, is just p plus q. And our constant term, c, well, that's p times q. Now imagine we had a perfect square trinomial, x plus p times x plus p, or you can think of that as x plus p squared. Remember, p is just some number. Well, if we were to multiply that out, we would find that b then is p plus p, or you can think of that as 2p. And our constant term is just p squared. And knowing that, we can come up with a relationship that as long as we have a perfect square trinomial, our constant term c is equal to b over 2 squared. So if I had x squared plus 8x plus c, and I told you this was a perfect square trinomial, we can find our c value. We would just plug in 8 for b, and that would look like c is equal to 8 over 2 squared. Now 8 over 2 is 4, so we'd have 4 squared, so our c is equal to 16. So if this is a perfect square trinomial, it's really x squared plus 8x plus 16. So now that we know the relationship between our linear coefficient b and our constant term c, let's talk about completing the square. Now remember, c is equal to b over 2 squared if we have a perfect square trinomial. In our first example here, we have x squared plus 12x plus 36 is equal to 25. Well, this left-hand side here is a perfect square trinomial. If I plug in 12 for b, I'd get 12 over 2 squared, or 6 squared. Well, 6 squared is 36. So because this left-hand side is a perfect square trinomial, I can factor it into x plus 6 times x plus 6. And this is still equal to 25. Or I can call this x plus 6 squared is equal to 25. So I've factored this left-hand side just because I know it's a perfect square trinomial. Let's look at our next example. Here we have x squared plus 6x is equal to 16. Well, my left-hand side here is not a perfect square trinomial. But if I take this 6 and I plug it in for b, I can find a c value. If I do that, I'll have c is equal to 6 over 2 squared. Now 6 over 2 is just 3, so we'd have 3 squared, and that's equal to 9. Now when you complete the square, you take a quadratic equation that's not a perfect square trinomial, and you force it to be a perfect square trinomial. If I had a constant term on the end here, plus c, that would make this left-hand side a perfect square trinomial. So what I'm going to do is I'm going to add 9 to the left-hand side. If I add 9 to the left-hand side, though, I have to add 9 to the right-hand side, because otherwise I would change the value of this expression. But if I do this, I'll have x squared plus 6x plus 9 is equal to 16 plus 9. Now by adding this 9 to both sides, I've made the left-hand side here a perfect square trinomial. And I can factor this out into x plus 3 squared. Now 16 plus 9 is 25. So I found that the factored form of this equation is x plus 3 squared is equal to 25. By adding this 9 to both sides, I have forced the left-hand side of this equation to become a perfect square trinomial. And when you do this, that's called completing the square. So now let's see how we can use completing the square to solve a quadratic equation. Here we have x squared minus 20x plus 42 is equal to 0. Now this left-hand side is not a perfect square trinomial, but we'll complete the square and we'll force it to be one. So we look at our b term here, and it's negative 20. So what we do is we plug that in and we solve for our constant term. Remember, c is b over 2 squared. Now my b is negative 20, so I'll have c is equal to negative 20 over 2 squared. Now negative 20 over 2 is negative 10, so c is equal to negative 10 squared, or my c is just equal to 100. So what I'm going to do is I'm going to take this 100 and I'm going to add it to both sides of my equation. If I do that, I'll end up with x squared minus 20x plus 100 plus 42 is equal to 100. Now this right here is my perfect square trinomial. This I can factor into x minus 10 times x minus 10. Or you can think of that as x minus 10 squared. Now don't forget about the 42 and the 100 on the right-hand side. I have just completed the square. Now that I'm done completing the square, I can actually solve this for x pretty easily using square roots. First, I'll subtract 42 from both sides. I'll end up with x minus 10 squared is equal to 58. My next step would be to square root both sides. Now if I take the square root of a square, I end up with the absolute value. So I have the absolute value of x minus 10. And that's equal to the square root of 58, which is not a perfect square, so I'm just going to leave it as the square root of 58. Now when I drop the absolute value, I have to consider both the positive and negative versions of my answer. So we'll have two equations. X minus 10 is equal to the square root of 58. And we also have x minus 10 is equal to the negative square root of 58. My last step will be to add 10 to both sides on both equations. And we'll end up with x is equal to 10 plus the square root of 58, and x is equal to 10 minus the square root of 58. So these are my solutions for x that will satisfy this equation. Let's try our next example. Here we have x squared plus 16x is equal to 12. Now again, we do not have a perfect square trinomial. So we're going to complete the square and force the left-hand side to be a perfect square trinomial. So we're going to add a number to both sides. And what number we add? We just use the formula c is equal to b over 2 squared. Our b is 16. So we'll have c is equal to 16 over 2 squared. Now 16 over 2 is 8, and 8 squared is 64. So what we're going to do is add 64 to both sides. If we do that, we'll end up with x squared plus 16x plus 64 is equal to 12 plus 64. Now this right-hand side is now a perfect square trinomial. And this will factor out into x plus 8 times x plus 8. In my right-hand side, 12 plus 64, that's 76. Now I can rewrite this x plus 8 times x plus 8 as x plus 8 squared, and that's still equal to 76. So I've just completed the square, and now I'm going to use square roots to solve this for x. I'll take the square root of both sides. If I do that, I'll have the absolute value of x plus 8, and that's equal to the square root of 76. Now I drop my absolute value, so I consider both the positive and negative versions. I'll have x plus 8 is equal to the square root of 76, and x plus 8 is equal to the negative square root of 76. Now I subtract 8 from both sides on both equations, and I end up with x is equal to the square root of 76 minus 8, and x is equal to the negative square root of 76 minus 8. So these would be our solutions for x. If you wanted to convert the square root of 76 into a decimal, the square root of 76 is equal to about 8.72. So our values for x in decimal form then would be 0.72, and negative 16.72. Either way. Now, up until now, whenever we've completed the square, we've always had a leading coefficient on our quadratic term of 1. But in these problems here, we don't have a leading coefficient of 1. We have a leading coefficient of 2 and 3. Now, because our leading coefficient is not 1, that means we cannot complete the square. So the way to solve these problems then is just to divide through your whole equation by your leading coefficient. In this case, 2. So if we have 2x squared plus 32x minus 34 is equal to 0, we would divide everything by 2. If we do that, we end up with x squared plus 16x minus 17 is equal to 0. Now this is not a perfect square trinomial, but if we can make it one by completing the square, remember our constant term, if we have a perfect square trinomial, is equal to b over 2 squared. My b is 16, so my c would be equal to 16 over 2 squared. So my c is equal to 64. Because 16 over 2 is 8, and then square 8, you get 64. So what I'm going to do is I'm going to add 64 to both sides. If I do that, I'll end up with x squared plus 16x plus 64 minus 17 is equal to 64. This here is a perfect square trinomial. This is x plus 8 times x plus 8. Or you can think of that as x plus 8 squared. And don't forget about your 17 and the 64 on the other side. So we factored this down into x plus 8 squared minus 17 is equal to 64. I want to get my squared term alone if I'm going to solve this, so I'm going to add 17 to both sides. If I do that, I end up with x plus 8 squared, and that's equal to 81. Now if I want to solve this for x, I have to take the square root of both sides. If I take the square root of a square, I end up with the absolute value. So we have the absolute value of x plus 8, and that's equal to the square root of 81, and the square root of 81 is just 9. Now if I drop the absolute value, I have to consider both the positive and negative versions. So we'll have x plus 8 is equal to 9, and x plus 8 is equal to negative 9. My next step will be to subtract 8 from both sides on both equations, and we get x is equal to 1 and x is equal to negative 17. So my solutions for this quadratic equation then are x is equal to 1 or x is equal to negative 17. Let's try our next example. Our next example is 3x squared plus 18x plus 12 is equal to 60. Now again, I have a leading coefficient here other than 1, so I need to divide everything by my leading coefficient. So I'm dividing every term by 3. If I do that, I'll end up with x squared plus 6x plus 4 is equal to 20. Now my left-hand side here is not a perfect square trinomial, so I'm going to force it to be one. I need to find out what my c will be, or what I'm going to add to both sides to make it a perfect square trinomial. My c is going to be equal to b over 2 squared, and my b is 6. So c is equal to 6 over 2 squared. 6 over 2 is 3, and 3 squared is 9. So my c has to be 9 if I have a perfect square trinomial. So what I'm going to do is add 9 to both sides. If I do that, I end up with x squared plus 6x plus 9, and then plus 4, and that's equal to 20 plus 9. Now this here is a perfect square trinomial. I can factor that into x plus 3 times x plus 3, or x plus 3 squared. Don't forget about our plus 4. And on the right hand side, 20 plus 9 is 29. Now if I'm going to solve this for x, I need to get my squared term alone on one side of the parentheses. So I'm going to subtract 4 from both sides. I'll end up with x plus 3 squared is equal to 25. Now if I want to solve for x, I have to take the square root of both sides to get rid of my square. If I take the square root of a square, I end up with the absolute value of x plus 3. And that's equal to the square root of 25, or just 5. Now when I drop the absolute value, I consider both the positive and negative versions. So I have x plus 3 is equal to 5, and x plus 3 is equal to negative 5. My last step is to subtract 3 from both sides on both equations. If I do that, I'll end up with x is equal to 2 and x is equal to negative 8. So my solutions for this equation are x is equal to 2 or x is equal to negative 8. And that completes the tutorial on solving quadratic equations by completing the square.